Good morning. Now we are discussing about the Malus law. The law states that the intensity of the polarized light transmitted through the analyzer is proportional to the square of the cosine of the angle between the planes of transmission of analyzer and polarizer. I repeat again, the intensity of plane polarized light transmitted through the analyzer is proportional to square of the cosine of the angle between the planes of transmission of analyzer and polarizer, and which is clearly explained in figure. This is the plane of analyzer, this is the plane of polarizer. The angle between these two planes is given by theta. The light or the intensity of light coming out of the analyzer is directly proportional to square of cosine of the angle between these two planes. In the sense, intensity of light coming out of this plane is proportional to cos square theta, where theta is the angle between the plane of polarizer and the plane of analyzer. Now, so let us consider the angle between the plane of polarizer and plane of analyzer as theta, as shown in figure. Let OP is equal to A represent the amplitude of the plane of polarized light, the amplitude of vibrations of the emergent plane polarized light from the polarizer. Now, if we resolve this A into two components, one will be A cos theta and the other will be A sin theta. A cos theta is in the plane of analyzer, and A sin theta is in a plane perpendicular to the plane of analyzer. Since the parallel components will be transmitted through the analyzer, whereas the perpendicular components will be reflected back. Hence, the intensity of transmitted beam is I is equal to A cos theta whole square, or it is A square cos square theta, or simply I equals I naught cos square theta, where I naught is equal to A square, called the intensity of the plane polarized light incident on the analyzer. And this we call it as the Malus law. We have different special cases. If theta is 0, in the sense if both the planes are parallel to one another, if the plane of polarizer is parallel to the plane of analyzer, then as we have the expression I equals I naught cos square theta, it becomes I equals I naught cos square theta is the Malus law. I equals I naught cos square theta is our Malus law. If theta become equal to 0, then cos square 0 is 1. Therefore, I will be equal to I naught. Hence, the intensity of light transmitted through the analyzer is maximum. And if theta is 90 degree, in the sense if the plane of polarizer is perpendicular to the plane of analyzer, if they are in that position, they are said to be crossed. If they are in the crossed position, then cos 90 becomes equal to 0, therefore I is equal to 0. No light will be transmitted through the analyzer, and all the light will be reflected back. And if theta is 180 degree, again cos 180 is minus 1 whole square is again 1, and therefore I is equal to I naught. Hence, most of the light or the intensity of light transmitted through the analyzer is maximum. And again, if theta is equal to 270 degree, finally cos 270 is again 0, and therefore I become equal to 0. And so for one complete rotation of the analyzer, the intensity of light varies between maximum and minimum twice. And this clearly indicates that if the intensity of light varies between maximum and minimum twice for one complete rotation, the light is said to be completely plane polarized. This is about the Malus law. Thank you.